All right, welcome back. So we now want to look at what the ratio test tells us about the series 1 over k. Now we already know that the series 1 over k diverges. We know that from our integral test. But we want to see, what does the root test tell us? Does the root test also tell us that? Or does the root test maybe give us an inconclusive result, like the ratio test? Does it fall short? Okay, that kind of becomes our question, because remember with the ratio test when we did this, the ratio test with the harmonic series landed us into an inconclusive result. Okay, so does the ratio root test also have that same limitation, or does it actually succeed where the ratio test failed? Okay, so once again we compute our limit as k goes to infinity of 1 over k, so the kth root of 1 over k. So rewriting that, that would be the limit as k goes to infinity of 1 over k raised to the 1 over k power. Okay. And unfortunately, that becomes a 0 to the 0 limit, which is again an indeterminate form. So to compute that limit, 0 to the 0, we would once again apply the logarithm. Okay. So we turn around and we look at the limit as k goes to infinity of the ln of that stuff, 1 over k to the 1 over k. That transforms that into the limit as k goes to infinity of 1 over k times the ln of 1 over k. All right, and at that point now, we have transformed the problem. We have transformed the problem into a 0 times infinity limit, right? All right, 1 over k as k goes to infinity is 0. As 1 over k goes to 0, ln is going to go to negative infinity. So we have now an infinity times 0 limit. Infinity times 0. So remember to handle an infinity times 0 limit. Right. We take one of those things over the reciprocal of the other. Okay, so limit as k goes to infinity. Of course, the simplest one to do is ln of 1 over k. Put that on top over the reciprocal of 1 over k. P over k. All right, that transforms this into an infinity over infinity limit, where we can now finally apply L'Hopital's rule to take the derivative. Limit as k goes to infinity. Derivative of ln of k would be the reciprocal of ln of k, so 1 over k, which should actually be k, times the derivative of 1 over k, which would be minus 1 over k squared. All of that is over the derivative of k, which is 1. So simplifying with the limit as k goes to infinity of minus 1 over k. But as k goes to infinity, minus 1 over k is going to go to 0. That means that the original limit we were looking at, limit as k goes to infinity of 1 over k to the 1 over k, is equal to e to the 0, which is equal to 1. And so, unfortunately, the root test is also inconclusive on that 1 over k sequence. All right, the root test is unfortunately inconclusive for that 1 over k sequence as well. So that harmonic series is kind of that thing that's right at the verge of converging, but it's just not quite there. And so, unfortunately, the root test, just like the ratio test, it lands at that inconclusive mark. Now, of course, that's okay for 1 over k because we know by the integral test that it diverges. Okay, but it's right at that cusp where we just don't know. So it also, once again, is actually inconclusive. Okay, so it's kind of that example that we like to use because it actually does not work for some of these more advanced tests, but we still have our integral test in our back pocket, and therefore we're able to still handle it. And again, this kind of presents the idea of why we have these different tests, because no one test works well for everything, or even works for everything.